This film is about the advantages of using dynamic balancing valves instead of static balancing valves in heating and cooling systems. In short, you can reduce pump energy consumption by up to 50%, as well as save time and contribute to a greener world. Let's first take a look at how to commission a system with static balancing valves. In this simple 3-branch system, we want to achieve a flow of 400 liters per hour through each branch. The flows through each branch can be read from the flow meters in the demonstration system. However, in a real system, the valves are inaccessible and flow meters are seldom fitted. We adjust the first valve to the desired flow rate and then we move on to the next valve. When the flow in one branch of the system is adjusted, the flows in the other branches change. So we have to repeat the process a number of times until we have the correct flow in all of the branches. This can be a time-consuming process, especially in larger systems. When temperature control valves change position in a system fitted with static balancing valves, flows to other parts of the system are affected and the system becomes unbalanced. You can determine the flow in a static balancing valve by measuring the pressure differential across the valve with a manometer and cross-referencing the measurement with the valve's data. The entire process is completely different in systems fitted with dynamic balancing valves. Now you can simply set the flow using a graph, no measurements. Alternatively, you can enter the desired flow into a software program that calculates the set point for the valve. The valve can then be set to the correct set point and the desired flow is achieved. In contrast to the static balancing valve process, when a temperature control valve changes position, the flow in other parts of the system is not affected. Even when the pump pressure changes, the dynamic balancing valves continue to maintain the set flow, whereas the flow in static balancing valves will fluctuate. In the case of a dynamic balancing valve system, you only need to measure the differential pressure across the index valve. This ensures that the pump uses as little energy as possible and that the required flow rates are maintained. In this case, it is not necessary to measure the differential pressure across the valve to set the flow, but instead to optimize the pump speed to achieve the greatest possible energy saving. If you expand the system in the future, there is no need to repeat the full commissioning process. Instead, just increase the pump speed to deliver the required pressure to the index valve, because the system will always be in balance.